Okay, we've all heard the hype, right? Artificial intelligence is set to completely revolutionize medicine, promising us this amazing future of super fast, super accurate diagnoses. But what happens when these brilliant systems get it wrong? Well, that's what we're going to dive into. The reality of AI in the clinic is way more complex and honestly, a lot more dangerous than you might think. So let me just ask you this right out of the gate. Picture a cutting-edge AI. I mean, it's been trained on thousands of images to spot skin cancer. Now, do you think something as simple as just rotating that image could fool it? Could it make the AI get the diagnosis totally wrong?
Well, the answer, and this is pretty shocking, is yes. A simple rotation, something a human doctor wouldn't even blink at, can totally trick an AI into seeing cancer where there isn't any. And that fragility, that's the critical problem we're going to unpack right now. All right, let's kick things off with our first section, the promise and the peril. We're going to look at just how much AI is shaking up the world of medical diagnosis.
I mean, you can totally see the appeal, right? It's no wonder the medical world is so excited. You've got a tool that literally never gets tired, it can sift through a mountain of data in the blink of an eye, and, in theory, it gets smarter with every single patient file it looks at. It's basically designed to be the superhero that overcomes all our very human limitations.
But, of course, there's a flip side. And that brings us to Section 2, when good AI goes bad. Let's dig into some real-world examples where these incredible systems have, well, completely failed. And look, these aren't just hypothetical what-ifs. We're talking about real stuff. You had IBM's Watson for oncology, which ended up recommending unsafe cancer treatments because its training data just wasn't realistic. Then there was Google's AI for eye disease. Looked amazing in the lab, but then it just couldn't handle the messiness of a real clinic. And yeah, like we said at the start, some of these AIs are so fragile that changing just a couple of pixels in an image can make it flip a diagnosis from "you're fine" to "this is cancer." So the big question is, why? Why do these things fail? This breaks it down really well. First up, you've got data bias. That's the IBM Watson problem. The AI is only ever as good as the data you feed it. Then there's context blindness. The AI just can't make the jump from a perfect lab setting to a chaotic real-world clinic. And finally, what we've been talking about, brittleness. The system gets tricked by these tiny little changes that, any person would just completely ignore. And, these mistakes can get really, really weird. Get this. An AI could give two different diagnoses for the exact same problem, all because one doctor wrote back pain and another wrote lumbago. It just doesn't have that common sense, contextual understanding that's just second nature for a human doctor. Okay, now let's move on, because this is where it gets even more complicated. It's not just about the AI messing up. This section is about the allure of automation and the hidden knock-on effect it has on the human experts who are actually using these tools. Yeah, this brings us to this really interesting psychological idea called the appeal to authority effect. It's basically this weird tendency we have to just trust a computer. We're more likely to believe what an automated system tells us, even if our own gut, our own training is screaming that something's not right. We kind of see the machine as the boss. And just look at the data on this. It is absolutely staggering. So in one study, you had radiologists working by themselves, right? Their false positive rate, that means flagging a problem that isn't actually there, was around 51%. But when they were given bad information from an AI, when the AI suggested a problem that didn't exist, their error rate shot up to 86%. They were totally swayed by the machine, even when the machine was flat out wrong. So why does this matter so much? Well, because the stakes couldn't be higher. Medical errors already cost the U.S. healthcare system something like $20 billion every single year, not to mention the human cost. So if we roll out AI the wrong way, it doesn't just fail to fix the problem. It could actually make a truly devastating situation even worse. Okay, so enough doom and gloom. How do we fix this? That's what Section 4 is all about, building a better co-pilot. We need practical ways to bring AI into the clinic safely. And the key idea here is to stop thinking of the AI as the pilot flying the plane and start seeing it as a co-pilot, assisting the human expert. So, what does that actually look like? Well, here are some really clear, actionable steps. First, doctors have to see the AI as a collaborator, a tool that makes them better, not something that's trying to replace them. Second, let's use AI for its superpowers, crunching data, gathering information, basically handling the grunt work so the doctor can focus. And third, we've got to demand better systems. We don't want an AI that gives one single "this is the answer" diagnosis.
We want one that gives us a few possibilities, each with a confidence score.
And that all leads us to our final section, the future of diagnosis. This is really about figuring out how we move forward, how we balance all this amazing innovation with the one thing that is absolutely non-negotiable: patient safety.
So here's the blueprint, the game plan for doing this right. We need continuous feedback loops so the AI and the human experts are constantly learning from each other. We also need smart regulation from places like the FDA to make sure these tools are safe without killing innovation. And maybe most important of all, we need human-centered design. That means getting doctors and clinicians in the room from day one, helping to build these tools.
You see, the whole point here, the big takeaway, is that the goal isn't to replace doctors, it's to support them. It's about building tools that help them make better, faster decisions for their patients. The AI should be the incredible assistant, not the final word.
Because at the end of the day, the most promising future for AI in medicine is one that protects the things a machine just can't do, the truly irreplaceable stuff, like empathy, human judgment, and that powerful connection between a doctor and a patient.
And so that leaves us with the biggest question of all, doesn't it? As we race ahead with this incredible technology, how do we build an AI that genuinely helps our doctors without accidentally losing the art of medicine in the process?